given the fact that simulations learn slowly, added up to this version. So some of you have seen an earlier version of that. Basically, there's this similar simply there are extensions, so we look at
More periods. Again, periods.
So we have more implications basically. So the thing here is, so the focus is relative performance evaluation. So this is a joint paper with Princeton University. So relative performance evaluation goes back to Holmstrom as an idea, maybe you remember. So the idea was to filter the aggregate in a certain way from performance. So if you have some agents or you have teams basically to base the conversation on the transfers, on the transaction. So how this applies to executives? The idea is that executives who run firms also subject to some kind of aggregate shock, like the market for this. So the idea is that, again, following Holmstrom's theory, these things should be filtered from their compensation. So the benchmark, so they should be paid relative to something. This benchmark usually taking some form of performance in the industrial market. The point is that empirically, there is a vast empirical literature finding level or non-empirical evidence that this is actually possible. Probably stay here. Okay, so there are some ways that the question has been approached in terms of explaining why we don't observe relative performance, or at least some irregularities in the data. So the first one that I'm going to mention is Gavin and there is some journal finance, and there are a couple of other papers who deal actually with the fact that the executive can filter these shocks him or herself. Basically, can do hedging, so can start financial wealth, can use it for this purpose. Another explanation go to softening competition in high concentrated industry. So this goes back to Sarah Kumar, but usually the literature goes to Samuel and there are we focused on the third one, which is the role of the participation test rate. Now, Oyer in Journal of Finance 2004 considered broad-based stock option plans to basically try to explain them by changing outside opportunities for the workers in the company. 2006 Journal of Finance paper shows that there is some support of that empirically. The support being, so they take some proxy for the value of the side opportunity, which, as a matter of fact, is so how often, positive news basically about the trick here is that, of course, this can be related to talent, and it goes a bit further. But anyway, and so the idea if we extend that is that the outside opportunity may depend on the aggregate shock. So basically, in order to keep the executive, we need to match these changes, which may lead to result opposite to that performance. Another paper, this is regarding economic dynamics. They consider different marginal, so the aggregate shock has an effect on the marginal productivity of effort, and they managed a simple model to get violations of relative performance or symmetric performance. So what do? We consider the effect on participation and the effect on technology. We mentioned two other. The intuition coming from the dynamics, I think is one of them. Actually, our technology thing is a bit different, but we're going to talk about this later. Now, there is also a paper which was never published by Himmelberg and Hubbard around 2000, where they try to merge technology with participation, but they do, so they have monolithic continuous kind of shops. So in order to solve, basically, they linearize the constraints. So basically, this is really not the solution. Not linearize, approximate. Okay. So what is our framework? So we're addressing this from the point of view of optimal contracting. So there is not going to be any scaling. The story is about hazard, so effort is unobservable. Commitment is limited. At least what we care about is limited commitment on part of the agent. And there are aggregate shocks, which affects both first technology and the managerial side options. So the effect on the first technology go to the need to have relative performance, so basically the aggregate outcome would affect first individual outcome, but it also have the aggregate outcome which affect what is the value of the executive option. So how does it go? So principally easily managed to operate this class of technology mapping effort outcomes. The distribution of outcome depends on effort, so this is standard, and on the aggregate outcome, which is observable before contracting. This can be extended, so the contract can be before that. Maybe there is a renegotiation afterwards, so we should take some form of expectation that will assume risk neutrality for the principal. But I mean, in this version, we have the aggregate outcome is observable, and then the contract counts. So this single period contract, you see. And now the manager can decide option which value, but basically depends on the aggregate outcome. So, what is the timing? The timing is that first, the aggregate outcome is realized according to some distribution, this capital P. And this would determine the executives, the value of executives of side options, so basically, the polarization here. Let's say the principal is here, the manager, the principal is she, manager is here. So, it's easy to talk about it. So, the principal of the manager contract implementing some effort level and some compensation scheme, which is contingent on the outcome. So basically, it's mapping individual outcomes to managers. If the manager rejects, both parties enjoy their reservation. If he accepts, to exert some effort level, maybe not the same. So that the outcome is realized according to distribution conditional on the aggregate outcome, which has been observed, and on effort, which is not observed by the principal. And in the end, payment takes place, so the individual outcome is observed, and the principal pays the wage to the manager. So there is commitment to pay the wage. So a couple of assumptions. So let's consider the simplest possible model. So basically we have two effort levels, so say working hard and shirking, and two possible outcomes, say success or failure, or good or bad outcome. And thus some notation which I may use to do that. So pi is basically the probability of the law, or the probability of failure. So pi lower bar goes for the probability of failure conditional law. Then pi upper bar, one conditional higher. So the assumption is, so this assumption here says simply that the probability of success is higher than the high effort. So note that this pi is actually probability of failure. So this guarantees stochastic variance and is strong resistance to potential. So you will have, generally speaking, monotonic speeds. Now, the other assumption is about the utility. So the manager is risk averse. So it is a concave function of the wage. Strictly compensated increasing. And effort, utility of effort comes additively. And the principle is risk neutral, basically taking the output and fitting this process as forms. And minus the transfers on the wage paid to Okay, so the problem is very simple. So this is a standard moral hazard problem. So which so with hidden effort. So for example, you can find this moskovia. So what's happening here is that principle is maximizing expected utility, so that effort is from some feasible set, in this case is 2 effort levels, so that the utility promised under the contract is at least the reservation value, and so that the contract is incentive compatible, so that the effort under the contract is the one that is going to be implemented. Okay, so this here is an inequality constraint if we have 2 effort levels. Okay, so the different thing here is only that both the probabilities depend on the aggregate outcome, so the probabilities of the outcome, and also the managerial side option depends on the aggregate outcome. So far, we're general, we're going to do some assumptions very soon. So, well, it's very simple, so we can solve this thing. Solving this thing, what we get is that the wage that would implement low effort is going to be fixed. So basically, this is going to be the marginal effect of changing the outcome. So basically, all the effect would come from the change in the value of the outside optional gain. Okay, so if high effort is optimal, and we assume for simplicity that marginal effect is the same for all distributions, this is going to be the outcome. So basically, there are going to be 2 elements. The first one is as before the effect of the reservation utility. The second one is the effect on the probability. So this is the probability of failure, actually. So this is the marginal change in the probability of failure resulting from changes in the result in the aggregate outcome. That's some weighting factor. So this weighting factor is the additional utility of working hard over shirking relative to the contribution to the probability of success. So this is the contribution to the probability of success, not the disadvantage. So this thing is positive. And also K, we look at the problem. K is the minimum utility premium that would incentivize high effort. Okay, so this is the additional utility we should give in consumption term to the agent so that the incentive compatibility holds with equality. So we're going to consider a couple of cases here. The first case is that the distribution of the individual outcomes would not depend on the aggregate outcome. Okay, so this probability theory. This effect will disappear. The second one is that it does depend, so it is going to depend positively for cross-sector. First one, basically high aggregate outcome, or if you think high industry shock affects positively the particular firm's outcome. And this would be negative for a firm that we would call counter-cyclical. So maybe that's not a good name, so probably this is just relating to, if you think of shocks and not of outcomes, this relates to the correlation between aggregate outcome inside maybe an industry. Okay, so here we have two sub-cases, a pro-cyclical firm and counter-cyclical. Now, also we consider 2 possibilities that, so the standard one that the reservation utilities of the agent do not depend on the aggregate outcome, and the other one we assume pro-cyclical relationship. So basically saying that when the industry is doing fine, the demand for executive services increases. And basically, if supply is inelastic, this will go to more value for the person. In the current period, you can say that this is going forward. The analysis is if you consider that. Okay? So, VRU stands for very reservation utility, CRU for constant reservation utility. Now, let's see what the results we get. So, for the wages that implement low effort, so we're not saying what is optimal here. Maybe it's optimal to leave the agent to share. So, for low effort, for both cases, what really matters is the change coming from the reservation utility. So, if the reservation utility does not depend on the aggregate outcome, there is no change. If it does, then there is a positive change. So increasing the outcome, increasing the the fixed wage that would implement the law. Okay, so what happens with high? We have some differences. So case 1 is actually the same as the thing we saw previously, because in case 1 there is no dependence of the probabilities on the aggregate outcome, so everything comes from the reservation utility. So things are the same. Although here we're talking about 2 wages, right? So for case 2, where the probability do depend on the aggregate outcome, it depends really whether the firm is counter-cyclical or pro-cyclical. So if the reservation utilities don't change, then for counter-cyclical, for compensation will decrease in aggregate outcome. So we don't expect this as relative performance. If you take it broadly, so if you consider relative performance of being pay increasing in odd outcome, decreasing in aggregate outcome. But I mean, it goes in the spirit of Holmstrom because simply the aggregate shock affects negatively the individual shock. And for pro-cyclical firm, okay, that's relative performance firm, so compensation decreases in aggregate outcome. So if the reservation utilities, then we have 2 effects. So for compensation, so for counter-cyclical firm, the compensation would increase in the aggregate outcome. So here we have 2 positive effects. Positive effect coming from the probability structure, and positive effect coming from the increase in the reservation utility. While for pro-cyclical firm, it really depends which effects dominate. So I'm basically talking about this thing. Oops, about this. I'm really talking about this second thing. So it really depends which one dominates. Okay, so basically compensation would increase if the increase in the reservation utility dominates the increase in the probability of success weighted by this factor that I talked about before. So basically, in this case, we would not observe relative performance. So this is simply to say that observing or not relative performance, if we take this model to be true, depends on whether which effects is stronger, whether the effect coming from the market, the industry, or the effect coming from the first change in information. So now the caveat here is that, okay, we are talking about high effort, low effort. So, okay, one of them would be optimal initially, but the point is that maybe the change in the aggregate outcome also changes the optimal effort. So, we investigate that a bit. So, because we have additional uncertainty in the compensation coming from, so additional risk from the changes in the reservation utility, ex ante, so before observing the aggregate outcome, it's more costly to implement both low and high, simply because of individual rationality. So the point is which one would become more costly and when. So we have some results. Not very strong, but anyway. So the results are that increasing aggregate outcome reinforces low effort. So basically increasing the value of the side option for the manager increases, reinforcing in the sense that if low effort was optimal, it still persists to be optimal. So don't expect a change. While a decrease would reinforce high effort. So this result is very local, so marginal changes for a wide class of utility factors, so in particular current. And most of the constant relative reservation cases, so that means the one that empirically relevant. And also we can show this global methodologically. Well, of course we may talk about what happens when effort changes after this thing, but it's a bit messy, so I'll skip this. So now we have an illustration. Actually, how many minutes do I have? Okay, so we can illustrate this with criteria shock. Why? Because we want to see if we think the effect of the correlation, things like this. Let me just say maybe I will skip that. So here the problem is that we cannot solve for the optimal wage, even with normality assumed. So basically, if we go to linear wages, we can solve, and we may say a couple of things. So the slope, so this basically we think that the wage is a linear function of the output. So P may be shared profits, is always a fixed number. We have some results saying that the ratio would affect the intercept but not the slope. The effect on the intercept would be proportional to slope being vectors. And also this would happen with very reservation theory, but the results come with more methods. So slope is nice, intercept is not. This is just an illustration. We have some other results that make sense, but nothing surprising there. Now, another illustration that we do is how the thing goes dynamically. So while we are doing that, first we want to see how effort would change and basically whether this intuition coming from the static model works here as well. So what we're doing, we're taking this initial problem with the discrete outcomes, and we're running this infinitely. So the connection between periods, so we basically assume that aggregate outcome, because remember aggregate outcome was observed before contracting. We just say that aggregate outcome is identically distributed in time here, basically for the numerical. We're going to estimate this way. For the numerical estimation, we just take that it's 1/2 probability. So we have two cases for aggregate outcome. In previous, we need lack of commitment. So for the options, two outside options to make one part of the agent, we may introduce one for the principal as well. So how this is addressed? This thing is going to be stationary on the Cartesian product of aggregate outcomes and agent's continuation. So basically standing state space, and we can solve this through a 2 or 3 step algorithm. So just a couple of words. First, we get the state space, following the Brew-Pearson stochastic paper. Okay, extend it a bit. Then, on this state space, we run value function iterations. And if principal can commit, we're done. If not, we should run one more iteration. So now I want to talk about the result. So you may say this, I just take the parameters like this. It's not exactly the case, but I mean, this is just an illustration. So what we see here is, here we see, so on the x-axis is the continuation utility. So the utility promised the agent. So basically, this is the state space for the particular. And these lines here, these are wages. I'm just showing wages, nothing more. So okay, so what is this? The star shows what's the case when the firm is low, and the blue line shows what's the case when the firm outcome is high. Now, basically, this thing is monotonic in the sense that the blue line is over the black one. Now, you might forget the right part of the graph. It's simply a consequence of the fact that I assume that the firm cannot borrow more than what it gets in terms of outcome to pay the agent. So which basically usually cuts the thing so much that the principal can communicate. So what I'm saying is that if the outcome is high, the agent can get up to this high outcome. If the outcome is low, so this is the stars, here the distance rate will become bounded, so it can get as much as if you take profits, for example. So you cannot borrow. Otherwise, these two things would be the same. So from the moment of time that they coincide, we take direction because there is also the fact of the continuation utility being used as part of the sentence. So from then on, we have so basically this more or less somewhere here. Effort becomes, so for these guys, effort becomes, it becomes optimal to be able to share. So basically these guys have fixed range after this thing happening here. Okay? Now this is the case where nothing is really happening. So the probability do not depend on the aggregate outcome, and the reservation utilities are constantly across outcomes. So we have like 2 minutes. Okay. So? Approximately. Okay, so let's speed up a bit. I'm trying to show you like 8 graphs. So what's happening here? This is the case where the probabilities do not depend. So the individual outcome do not depend on the aggregate, but the reservation utility does. And it does positively so. So what we see is that this is firm low and firm high in the industry is low. Okay? So this is the gray thing is firm low and industry output is low. And these squares here, the purple ones, are firm high and industry low. Okay? So what we see basically that this thing mostly coincides. So it seems that there is not effect really of the reservation, but there is because you see the thing starts here. So there is a cap on the possible continuation values if the outcome is low. So actually this thing here is for high industry outcomes. For high industry outcome, we have that the minimum possible continuation utility is equal to the exogenous bound, which is in the reservation utility. Here it's not. This thing is moved a bit, but still it's, here it's not. This thing is moved a bit because actually what is the other one is like some way here should be the bound for the loss thing. So what we get is that higher reservation utilities because of the higher bound in the where industry is high. High reservation utility, so high configuration utilities should be supported than otherwise, where the industry was over. Basically what I'm saying is that if you consider this graph, the scale is the same. Compare with this one. So the scale is the same, so basically the thing shrinks in this direction. Okay, and, so if we have effects on the probabilities and there is no change in the reservation utility, then what's happening is that, okay, so here we have that the probability of aggregate, so higher outcome means higher probability of success for the firm as well. So in this case, we would expect relative performance, and we see basically when the highest value here is when firm is high and industry is low, so relative performance. Okay? Now, if the thing is counter-cyclical, we have the opposite thing. So here is firm high industry. So it's firm high industry low, but there is change for firm high industry high. So firm high industry high for the green line. Sorry, this is both effects coming together. So from this one. So final words, okay? So I'll just say that the intuition holds, and my final words are that there are 2 more effects that come here. So one of them is the effect from the continuation value. So you see that the continuation values, even for this case, are used also as incentives. So the extent of the relative performance observed if we take current wages would be different if the model is really dynamic, because part of this would come from incentivizing effort through continuation utility. So this is coming dynamically. And this thing that took me a lot of time, but actually is also nice. So this thing is just showing you what happens if I was talking about limits on the right side. So this is what happens. Okay, if the limit of the outside so if the borrowing limit is procyclical, if the borrowing limit is procyclical, we observe something like this. Simply, relative performance will not hold in this region because borrowing constraints won't bind when the economy is low or the industry is low. Okay, so sorry for, yeah.
Thank you.
Okay, so this is a nice paper. Let me explain the main point and then summarize and then give a few comments. It's basically about contracts in the principal agent setting, and sometimes you observe information which affects the agent's performance, but it's not the agent's fault. So the question is, when is it optimal to filter out this information. So this intuition from Holmstrom tells us that we should filter out any aggregate information that the agent cannot directly affect with his actions. And this paper says that under certain conditions it's not optimal. And for example, when this aggregate variable is correlated with the agent's outside option. So the model goes like this. At the beginning, there's some aggregate outcome that's realized, which might affect the agent's performance. So the agent puts unobservable effort, and the agent's effort affects the probability of output. So the probability of output depends on the agent's effort and also the aggregate outcome. So that has effect on the outcome. So the agent has fairly standard utility. He likes to be paid and he doesn't like to work. And the principal offers the agent a contract which specifies how the wage is going to depend on the output and the observable aggregate outcome. Aggregate outcome will be filtered out if the wage does not depend on the aggregate outcome. So the problem is to maximize the principal's profit subject to giving the agent at least his reservation utility. So a crucial assumption is that the aggregate outcome affects the agent's outside option, his reservation utility. And this is an incentive constraint. So crucially, this particular constraint says that the agent has to get at least his outside option, which depends on the observable aggregate outcome. And so in order to make the analysis simpler, the paper first focuses on the case of two effort levels and two outcomes. High effort makes high output more likely. Let's assume for simplicity that the probability of outcome actually depends on the agent's effort but does not depend on the aggregate outcome. So then this seems to be completely irrelevant information. But in fact, because it affects the agent's outside option, it is going to affect the contract. And so the agent's pay is going to depend on the aggregate outcome. If the principal is trying to implement low effort will be implemented by a constant wage contract, and the wage is going to be increasing in the agent's outside option. If the principal is trying to implement high effort, then the agent's wage is going to depend on the output, whether it's low or high, and both of the wage after the low outcome and the wage after the high outcome is going to be increasing in the agent's outside option. Okay. So the paper also considers a case where, this I find is an important result that obviously the wage depends on the aggregate outcome. So the paper also considers a case where the output depends on this variable YA, and in this case there are many different cases, and results could turn out to be going different directions. So apart from the main one-period model, the paper also has a bit of a different model, and it also has a multi-period example. So here, output depends on effort, depends on some aggregate observable shock, and it depends on random unobservable shock. So in this case, if the paper restricts attention to linear contracts, then a linear contract consists of a constant wage and the piece rate. So for the case when the aggregate variable is uncorrelated with the agent's outside option, what happens is that this aggregate variable affects the fixed wage but does not affect the piece rate. And effectively, what happens here is that aggregate information is being filtered out if it is uncorrelated with the agent's outside option. But if it is correlated, then it affects both components of the contract. So here also, the aggregate variable is not filtered out. The paper considers a dynamic model where this is basically the one period model repeated period after period. And the agent's outside option could be either IID across periods or it could be Markov. I think in the computation of the paper it is IID. And in the dynamic model also, the aggregate variable does affect the agent's wage, obviously, because the principal should care about the agent's outside option. So the paper makes a nice point, and this computation is actually not easy. So it's an impressive achievement of the paper. So I just wanted to point out a few related papers. So related to the question of when it's optimal to filter out some observable information about the agent's performance and when it's not. And the general intuition is that it's not optimal to completely filter out, well, in this paper, something correlated to the agent's outside option. But there are papers where this aggregate variable is correlated with the firm's future profitability. And in those cases, it's also not optimal to filter out. So there are papers, Hoffman and Feil, DeMars, Fishman, Hin, Wang, Piskorsky, and Chiste, which make this point. When an aggregate variable is correlated with the firm's future profitability, then the agent's payoff is going to depend on the aggregate variable. So these papers, they use continuous time to make this point in the dynamic model. So some other suggestions. So I like this model with linear contracts. So in the paper, the linear contracts are not optimal, but the model seems very related to Holmstrom and Milgram. So maybe it's possible to tweak the model somehow to make the linear contracts optimal. And computation, so I think that the computational exercise in the paper is very nice. In the paper, I read the draft, and the paper should go into more detail describing, how computation is performed, because that's useful. So the paper does computation in discrete time, which is not easy to do. I know that there is a paper by Phelan and Townsend which proposes one method how to compute things in discrete time. So I was talking with Stanimir yesterday, and he described that he uses a slightly different method, but related. And just a suggestion, computation is actually much easier to do in continuous time. So it's possible to rewrite this as a dynamic model in continuous time. It might be possible to get much cleaner pictures and with a lot less effort, sitting in front of the computer programming. So just to conclude, this paper brings a nice and important point that there's this one situation where it's not optimal to filter out aggregate uncertainty despite Holmstrom's intuition. And computational exercise is, of course, impressive. And I enjoyed reading the paper.
Ideally, the aggregated state of which you are conditioning shouldn't be the aggregated outcome of many firms playing the same game.
Could be.
I see. That would generate multiple equilibrium if you were to. Sorry. This potentially generate multiple equilibrium if you were to generalize it. right? We are a continuum of firms that play the same game, and YA is the...
Yeah, if you put in the generality, I suppose, yes. So here basically we're taking this as given. And I mean, if you say that there are not many firms in the industry, and if you say that this executive can go only in this industry, so then the problem becomes a bit different. So the generalization maybe needs, okay, it's not going to be trivial.